So here we have a few different kind of force problems. So we'll take it from the top. Number 1 says the helicopter accelerates upward 3.5 meters per second squared. Jim has a mass of 60 kilograms. Calculate the tension in the rope. Well, we have Jim that's hanging from a rope, and the helicopter is going to have an upward acceleration. So we're going to start by making our force body diagram. So we have force of weight, which is always straight down, and force of weight is equal to mass times gravity. So in Jim's case, his mass is 60, and we will count gravity as 10, so we'll just call this 600 newtons. Okay, but he also has a tension force up. Okay, since he's accelerating upward 3.5 meters per second squared, we know that the tension force is going to be greater than the force of weight. So if we go ahead and make our sum of our forces formula, we have T, which is going up, so it's going to be positive, minus force of weight, which is negative. And since these are all the sum of my forces, so up here I'll write this, the sum of my forces, this is in the y direction, is going to equal my mass times my acceleration in the y direction. Okay, so I have my mass times acceleration. So tension is what we're solving for. Force of weight we know to be 600. Mass is 60 for Jim, and his acceleration is 3.5 meters per second squared upward. Alright, so we can move this 600 to the other side. So tension will basically be 600 plus 60 times 3.5. So I'll plug this into our calculator. Okay, 600 plus 60 times 3.5. And we get 810 newtons. Now we anticipated the tension being greater since it's accelerating upward, and it is. Alright, number 2 says diagrams only. So they want a force body diagram with friction and without friction. Well, if we have with friction, actually either way, we are going to have the force of weight that is always straight down. We are also going to have a normal force, which is perpendicular to the surface. Alright, and if we had friction, friction will be going up the ramp, so opposing the motion that it wants to take downward. If we did not have friction, then there would be no frictional force. Now, some of you will think that you want to put a force right here, but actually the force that's being applied down the ramp is a function of this force of weight, which is already accounted for. So we can't actually put that force into our force body diagram because it's not an actual force, it's just a component of our force of weight. Okay, moving on. Number 3. Jim has a speed of 2 meters per second at the bottom of the swing's path. If the length of the swing is 1.5 meters, find the tension in the rope. Alright, so here we have tension, which at this point is straight up, and we have force of weight down, which is equal to mass times gravity. Alright, so we know the sum of our forces is going to equal ma. Well, if he is swinging, he is actually moving in a circular motion. Okay, he's making an arc right here, which means we have a very special type of acceleration, centripetal acceleration. Okay, so the acceleration here, centripetal acceleration, is always velocity squared over r. So for us, it's going to be 2 squared over 1.5. So 2 squared is 4, divided by 1.5, and our acceleration is 2.7. Or we can call that 2.67. Alright, well we know the sum of our forces equals our mass times our acceleration. So we have tension, which is up, minus force of weight, which is down, which is equal to mass times gravity, so 60 times 10 is 600, and that equals our mass, which is 60, times our acceleration, which we just calculated to be 2.67. So we could add 600 to both sides. On the left side, this would go away, so tension will equal 60 times 2.67 plus 600, 760 newtons. Alright. Number 4. Jim pushes up with 950 newtons. Calculate the acceleration of the weights, which are 70 kilograms total. Okay, so when we draw a force body diagram, we are drawing a force body diagram for the weights because we want to know the acceleration of the weights. Okay, the weights have a force of weight, which is mass times gravity, so 700 newtons, 70 times 10. But also, Jim is applying a force upward, so some kind of applied force, that is 950 newtons. Okay, and those are the only forces that are acting on the weights. So the sum of our forces in the x direction, or if this is the y direction, are going to be the 950 newtons, which is up, minus 700, which is down, and that equals the mass. So for the weights, it's 70 times acceleration. Alright, so on this left side, 950 minus 700 is 250, and that equals 70 times acceleration. If we divide both sides by 70, we can easily solve for acceleration, because 70 over 70 is 1. So 250 divided by 70 is our acceleration, which is 3.57 meters per second squared.